Homework 1 is an intro to sequences and series. So we've got a bunch of different types of problems. So you're going to get a really quick intro to everything. So the first set, we are finding the first 5 terms of each sequence. So these ones are defined recursively rather than explicitly. You've got a couple different types. So the first 5 terms, so we've got the first one is always written out. So the first term is 9. And then you can see a formula here. It says for the next term, you take the previous term and subtract 2. So the second one, you take 9 minus 2, and then 7 minus 2, 5 minus 2, and 3 minus 2. So it just keeps going, and then we hit the 5th term, and the pattern would repeat. It would go into the negative values after that. Let's go to number 5. So a possible recursive rule. This isn't necessarily like the recursive rule, but as long as it works, you'd be good on something like this. So the first term is 7. So you always start by writing that out, just like we have in these 4 problems. So you write the first term is 7, and then a recursive rule just based on the one before. So you can see the pattern is it goes up 5 every time. So the easiest way to write this is to say that each term is the term before plus 5, like that. All right, so you can work out, and then it says to find a of 7. So you can go through and figure out each pattern. So this is 1, 2, 3, 4, 5. So a 6 would be 32. That means a 7 would be 37. All right, number 7, this one is an explicit rule. So you're basically just plugging n equals 1, n equals 2, all the way up to 5. So this formula, if we have the first term, if we plug a 1 in here, 1 minus 7 is negative 6, times negative 2 would be positive 12. Next term would be 2, so 2 minus 7 is negative 5, times negative 2 would be 10. Term 3, 3 minus 7 is negative 4, times negative 2 would be 8. Term 4, 4 minus 7 is negative 3, times negative 2 is 6. And term 5, 5 minus 7 is negative 2, times negative 2 is 4. And then the pattern would just keep going. And you can see this would be a pretty easy one to define recursively. It's just going down 2 each time after starting at 12. For number 11, a possible explicit rule. These ones are a little bit trickier, and there are definitely multiple possibilities for each one of these. So let's say for a sub n, if this is the first term, the second term, the third term, you can see these are all going down by 1. So what you could say is term 1, you could subtract 8 from each one of them. That's one possibility. So if it's term 1, 1 minus 8 would be negative 7, 2 minus 8 would be negative 6, 3 minus 8, 4 minus 8, 5 minus 8. So that's just one possibility, is the term number minus 8s. You don't have to do it that way. There are a couple other options. That's just the first one that pops into my head. And then a 10. So since it's defined explicitly, you can just plug 10 into this formula. So 10 minus 8 would be positive 2. All right, so that's one explicit version. The last type on this page, number 15, find the partial sums. This is now getting into sequences and series. So partial sums, you would figure out all like the first 12, and you'd have to figure out what the pattern is first, then write down the rest of the 12 besides these first 4 that are given right here. So it looks like the pattern is going, we go down 7, down 7, down 7. So you could repeat that. We need to find 8 more terms. So down 7 would be 10, and then 3, negative 4, negative 11. So let's say that's 8 terms. Negative 18, negative 25, negative 32, and then negative 39 would be the last one. So the partial sum means that you are taking all of those values that you have and just summing them up, adding them together. So this is a capital S sub 12, and so it's just adding together the first 12 terms of that sequence. So we'd have 38 plus 31, and it's just all of these numbers that we have written down here, just adding them all together. Oops. Okay, so we end up with -6 when we add all of those together. So that is the 12th partial sum. All right, and then on to the next page. The next page we are expanding series and evaluating. So I'll just go with this first one right here. So this says to start with the first term, end with the 14th term, and the formula for each term is n-6. All right, so we go term by term, and we're just going to add 14 of them together. So the first term, 1 - 6 plus 2 - 6 plus 3 - 6 4 - 6 plus 5 - 6 plus 6 - 6. So now we're on the 6th term. We have up to 14 to go. Oops, sorry, I said 6 so many times that I wrote that down. 6 - 6 plus 7 - 6 plus 8 - 6 plus 9 - 6 plus 10 - 6 plus 11 - 6 plus 12 - 6 plus 13 - 6 plus 14 - 6. So you can see basically what happens when it's explicitly defined like this. There's almost like a slope sort of situation. So the slope is 1. That just means that each one of these values is going up by 1 each time. The -6 just figures out where term 0 would be if you had one. So term 1 just goes up 1 from there. So we add all these together. One thing I want to show you a way that we could do this without using a calculator. Notice you've got a lot of positive and negative values. So -5, +5, 4s, 3s, 2s, 1s, of course, 0 is 0. So like when you add each of those pairs together, you get 0. So it really would just be 6 plus 7 plus 8. So 6 plus 7 is 13, plus 8 is 21. So that would be the series evaluated.